Hi friends, my name is Praveen. Today I am going to speak about the mathematical expression for standing waves. And before going for the mathematical expression, let's understand what exactly a standing wave is. Two waves of same frequency traveling in opposite direction is superimposed. Then a wave which is stationary is created, and that is called as a standing wave. In order to create a standing wave, we have to combine two waves of same frequency traveling in opposite direction. Therefore, let's draw our first wave like this. Let this be our first wave, and it is traveling in this direction, and it is combined with another wave over here. This wave is of same frequency, but it's traveling in this direction. Let the equation of mathematical equation of first wave be y1 is equal to a sine omega t minus kx. This is the mathematical kx. This is the mathematical equation for the first wave. Likewise, the mathematical equation for the second wave, let it be y2, and I am writing y2 is equal to a sine omega t plus kx. Over here it is minus kx, and over here it is plus kx. It's because the first wave is traveling in this direction and the second wave is traveling in the opposite direction. Then these two waves are combining to form a wave which is stationary, and I'll draw the standing wave like this. That is, if the two waves are combining at one time, we could observe a wave like this, and the position of the wave will change to a pattern like this in a time interval, and the position will shuffle like this, and now this wave is called as a standing wave. And there are 2 points on the standing wave. These points on the standing wave, they are called as nodes. Because nodes are the points on the standing wave where the vibration is minimum. The point on the standing wave where the vibration is minimum is called as node. And these points on the standing wave, they are called as antinodes. Antinodes, they are the points on the standing wave where the vibration is maximum. That is, assume that our standing wave, this portion of standing wave, it will vibrate like this. That is, this portion will be node, and the middle of my hand will be antinode. Antinode will have maximum vibration and node will have minimum vibration. And this is the diagrammatic representation of a standing wave. Then let's go for the mathematical expression for standing wave. Y1 wave and Y2 wave will combine to form a standing wave. Therefore, the resulting wave Y, it should be equal to Y1 plus Y2. Then let's substitute for y1 and y2. A is common in both of the equation. Therefore, I am writing y is equal to a taken common out. Then it is sine omega t minus kx plus sine omega t plus kx. Then, referring this equation, we could transform this equation by using a trigonometric identity, that is sine A plus sine B, it is equal to 2 sine A plus B by 2 cos A minus B by 2. We are having a trigonometric identity like this, and we could use this trigonometric identity to transform this equation. Therefore, we could write y is equal to a into, instead of this bracket, we could write 2 sine Instead of A, we are having omega t minus kx, and instead of B, we are having omega t plus kx. A plus B by 2 means this term plus this term whole divided by 2. And if we are adding these two terms, this minus kx and this plus kx will cancel. Therefore, I could write omega t plus omega t is 2 omega t. 2 omega t by 2, it will be omega t. Instead of a plus b by 2, we are having sine omega t. And next is cos a minus b whole divided by 2. That means this term minus this term divided by 2. I could write it over here. That is omega t minus kx minus omega t plus kx whole divided by 2. On expanding this bracket, we could cancel this omega t and minus omega t. Minus kx, it will be minus 2kx. Minus 2kx by 2 is minus kx. Okay, we are having an equation like this. Then we could use another trigonometric identity, that is cos of minus theta is minus, it's not minus, cos of minus theta is cos theta itself. Sine of minus theta is minus sine theta. Cos of minus theta is cos theta itself. Therefore, I could rearrange this equation like this. Y is equal to 2 into a sine omega t cos kx. We are having our equation for standing wave like this. And this is the equation for standing wave. Then next, let's just analyze the distance between the two consecutive nodes. We are going to find out the distance between the two consecutive nodes. What is node? It is the point on the standing wave where the vibration is minimum. The point on the standing wave where the vibration is minimum is called as node. Therefore, the distance between two nodes means nodes will have minimum vibration. Therefore, for nodes, y should be minimum. If y should be minimum, 2a sine omega t, this won't change, then cos kx should be minimum. Then what is the value of cos kx to be minimum? If y is minimum means the cos kx value, it should be 0. Then let's understand a trigonometric identity, that is if cos theta is equal to 0, if cos theta is 0 means the value of theta, it should be, cos 90 is 0, therefore value of theta should be 90 means it is pi by 2, and it can be 3 pi by 2, 5 pi by 2, 7 pi by 2, etc. All the odd multiple of pi by 2, the cos value is 0. Therefore, if cos kx is equal to 0 means kx should be pi by 2, 3 pi by 2, 5 pi by 2, etc. And for first minimum, what should we do? For the first minimum, we should substitute the kx value as pi by 2. Therefore, I am writing it as k into x1. x1 is the first distance, is equal to pi by 2. I could write like this. And for second minimum, I could write, for second minimum, kx should be 3 pi by 2. Therefore, I am writing k into x2 should be equal to 3 pi by 2. Then, from these two equations, let me write what's the value of kx1 or kx2 minus kx1. From these two equations, I could find out kx2 minus kx1 should be 3 pi by 2 minus pi by 2, that is pi by 2 into 3 minus 1. Okay. Then this equation can be transformed as k into x2 minus x1 is equal to 3 minus 1 is 2. 2 and 2 will get cancelled. It is pi. And you already know the value of k. K is angular wave number and the value of k is 2 pi by lambda. Since the value of k is 2 pi by lambda, I could write 2 pi by lambda into x2 minus x1 is equal to pi. Pi and pi will get cancelled. As a result, ultimately, we could write what's the value of x2 minus x1. x2 minus x1, it should be lambda will go up, 2 will go down, that is lambda by 2. That means the distance between the consecutive nodes, it will be lambda by 2. In the similar manner, we could find out the distance between two consecutive antinodes also. That also will get the answer for distance between two consecutive antinodes also as lambda by 2. This is also lambda by 2. Hope you have understood this standing waves mathematical derivation. This is the mathematical equation for a standing wave. This one, and the distance between two consecutive nodes or two consecutive antinodes is lambda by 2. What is node? Node is the point on the standing wave where the vibration is minimum. What is antinode? Antinode is the point on the standing wave where the vibration is maximum. And what is a standing wave? A wave which is stationary is called as standing wave. How can we create a standing wave? We could create a standing wave by combining two waves of same frequency traveling in opposite direction. The definition of standing wave can be given like this also. If two waves of same frequency traveling in opposite direction is superimposed, a wave which is stationary is created. That wave is called as standing wave. Thank you.